Hello, Sal Prep. This is Mr. Ellinger, and I'm just going to go through assignment 25. And what I'm going to do is I'm going to do the odds. I thought, like a little bit of help for people, a little bit of assistance. So you're going to get help with the odds right now, and I'm just going to go through them. And this is just a supplemental video, so to help people want a little more practice and a little more support in doing these things. All right, here we go. Number 9. Integral of x cubed. I should say, I'm going to do the early odds. I might not get to everything. I might not do all the odds. I'm just going to do some of them. But, just give you a little more support here. Okay, so what do I do when I'm doing this integral? I notice that there's two pieces to it. So I can't just integrate it. I can't, integrate each one. And remember, the whole point of this, backing up a little bit, the whole point of this is that we're trying to come up with something that's the antiderivative. That's the goal. And so whatever we come up with whatever answer we come up with, we need, if we took the derivative of that we get our original function. I had a question from a follow-up question that Brighton asked afterwards, after everybody left. It was really good, where it was like, wait a minute, are we doing the derivative or are we doing the antiderivative? She didn't say it quite like that, but that's kind of like the fundamental part of the question. Was, wait, why are we talking about the derivative? I thought we were doing the antiderivative kind of thing. Awesome question. And the whole idea is we're trying to come up with the antiderivative. That's totally true. But the way we're viewing that is we're saying, okay, whatever we come up with, if we took the derivative of it, we'd get this thing as an answer. So we're constantly thinking about taking derivatives because we're taking the derivative of whatever we come up with. And that's why we can't say, x to the fourth with 1/4 and x to the fourth plus 3 to the third with a 1/3. We can't just antiderivative each one, because the question then is, what would happen if we took the derivative of that and then we'd get something totally different? We wouldn't get this as an answer because we'd have to do product rule and it'd be a mess, right? So that's the idea of what we're doing here, is we're trying to figure out what the antiderivative of this is, but we're thinking about taking the derivative of something and getting that as an answer. Whole key on this is I notice there's two functions. So I can't just do each one separately. That would involve product rule of my answer. And so I'm thinking chain rule here. And so I look at it and I go, oh, okay, here I've got an inside. I've got an inside. I've got my outside. And then I've got my derivative of the inside. Almost, right? This is a classic Lindstrom situation where I can make it perfectly the derivative of the inside, and then I can totally do the Lindstrom method. So I'm going to go, all right, the derivative of this thing, of x to the fourth, is 4x cubed. So I need a 4 there, but that means I need to balance it with a 1/4 on the outside, and now I haven't changed anything. Now we're going to do the antiderivative of the outside. So that's cubed with a 1/3. Right? Bump the exponent, divide it, leave the inside alone, and then the derivative of the inside just goes away. And then there's an extra 1/4 out there. If you're wondering, why does that work? Imagine taking the derivative of this thing. You'd multiply the 3 down. So that would cancel out this and would make the 1/3 go away. You'd drop the exponent by 1, so it'd be squared. You'd leave the inside alone, so it'd still be that, times the derivative of the inside, because of chain rule, and that would cancel out with the 1/4 I have there, and the 1/3 cancel out with the 3, and I get x cubed and x to the fourth plus 3, and that was what the original problem was before I started tinkering with it. So that's how I can tell I'm doing this right. Get rid of that. And so my answer then is 1/12 x to the fourth plus 3 to the third plus c. Boom. Okay. All right. Next one I'm going to do, 15 is the next one I'm going to do. And 15 I'm going to do with substitution, just to remind you on this. So you can totally Lindstrom this problem, but I want to be clear about it. Now I'll rewrite the problem as I write it down. I'm going to write it as an exponent instead of a cube root. X squared to the 1/3 dx. 5x, 1 minus x squared to 1/3. Okay, cool. So now the question that people asked is, how do I decide what to use for substitution? And the answer I gave, and I'm sticking with, is when we do the u, we want that to take care of some of the stuff in our integral. But then when we do the du, the derivative of that, then we want that to take care of some other stuff, you know? So like, trying to think if there's something silly I could make u. I don't. Well, I mean, someone could say, should I make u equal to 1 minus x squared to the 1/3? I'd say, okay, if you do that, then this whole thing here would become u. That seems pretty good, right? But then you're going to take the derivative. And so somehow then you need to have negative 2/3 times negative 2x. Somehow you're going to need to take that and use that to substitute out dx and 5x, and that's it. And so you can see how, like, ooh, this is going to be a problem here. Whoops, there's a dx at the end of that. You see there's going to be a problem with that. That's the du isn't something close to 5x dx. So, yeah, no, I don't want to do that. Okay, so instead, I look at it and say, well, all I got left is a 5x, and I have to take care of that when I do the du. So instead, well, I got to erase that too. Instead, I'm going to make du just be, u is just going to be, let's just make it x squared. Just that little part of it. So du is 2x dx. Cool. So now, all right, I'm going to substitute out. So this parentheses thing here becomes, actually, no. Ooh, could I change a little bit? Yeah, I was spacing out for a moment. Let's make it 1 minus x squared. That's the way to go. So and the du is totally the same, except it's negative 2x. All right, so this becomes u to the 1/3. Okay, cool. Now I've got that 5x dx that's still over there. Now you could do this a lot of different ways. Like, I mean, I could solve. I guess I'll divide the negative 2 over, and I'll get x dx, and I've got negative 1/2 du. I'm just trying to substitute out all the other stuff, so it just becomes a u problem instead of an x problem. All right, and so I can just move this 5 in front. I can get it out of the way. Constant multiple, and so x dx, that's what I have left over, just becomes negative 1/2 du. So negative 1/2, and it's all multiplying, du integral 5. And now it's a u problem, and it's something I can easily find the antiderivative for. So I'll just pull the negative 5/2 in front, get that out of the way. Now do the antiderivative. Bump the exponent, divide it, and plus c. So, and so now I should put it back into what it really is, and it's 1 minus x squared. So it's 1 minus x squared to the 4/3. And then I'm going to leave this here for a second. I'm going to erase it in a bit. Plus c. So checking my answer. Take the derivative. Multiply the 4/3 down. That would cancel out 3/4. Drop the exponent by 1. That would give me, and actually, wait, take a second. I'm going to make it look like the original problem so that I can check my answer easily. Multiply 4/3 down. That cancels out the 3/4. Drop the exponent by 1, and that gives me this thing here. So I got that thing taken care of. Times the derivative of what's inside. So it'd be times negative 2x. And the negative would cancel out the negative with the negative there. Good. And the 2 would cancel out with the 2. There'd still be that 5, but I expect there to be that 5. And so I'd have a 5x in front. You can take the derivative yourself and convince yourself that it's true. Let's see what that's. Well, I can't cancel any of that. If I could cancel something. Negative 15 over 8. Like the fraction doesn't reduce. To the 4/3 plus c. Okay, so I've done one substitution, and I've done one Lindstrom, and I'm going to go a little bit quicker, so it'll be more like checking work for a bit. 21 integral x square root 1 minus x squared dx. Ooh, we did this one. Did I actually have this one? We'll still go over it. It doesn't matter. Okay, I'm going to Lindstrom. So I think of this as a negative 1/2, but I first need the derivative of what's inside to be present. So I'm going to multiply this by negative 2 and negative 1/2, because the derivative of negative x of 1 minus x squared is negative 2x. Now the derivative of what's inside is there. So it's we had one a lot like this. That's right. It's 1 minus x squared to the 1/2. I bumped the exponent with a 2 over 1. Yeah, I remember the problem now that we had. And so that's just 1 minus x squared to the 1/2. You could do square root if you want to. It doesn't matter. Plus c. Yeah. And if you want to, you can check your answer, multiply down, and negative. So I missed that one initially, because I was going fast and I'm talking the whole time and stuff. But I missed that there's a negative in front of that and I got that by checking my answer. I multiply the 1/2 down, drop the exponent by 1, times derivative what's inside, which is a -2. And so I could see that I was getting a negative x on top when I did it. But the negative, I just forgot about this negative that was right here. That didn't get canceled. Go away, whatever you are. There you go. Okay. I can really quickly see about one more. I got time for one more. And let's help with odds. Sorry, I got to see what the next odd was and see if it's a good one. 25, I'm going to leave. 25 is fine. 35 is fine. Sorry, I'm just like making sure. Ooh, okay, yeah, that's kind of it. Yeah, and that's 79. Yep. Yep. Ooh, you know what? I'm going to show you. What the heck? You're going to get an even. I'm going to show you number 60. So this will be the next thing. One of the next things that we were going to get to was doing a definite integral. So I'm going to do number 60. Okay. Make sure you're trying these though. It's the only way you're going to learn them is by trying them yourself. I know it's a lot like the other one, but I'm just going to talk about something. So it's the integral from 0 to 2 of x over square root of 1 plus 2x squared dx. Okay? I'll do substitution. I'm going to make u equal to 1 plus 2x squared. So that whole denominator will become square root of u. That's nice. And so du is, I'm only doing u substitution for variety because I'm trying to be helpful, is 4x dx. And I only have x dx in the problem, so I might as well divide the 4 over. So 1/4 du equals x dx. I love when I can to just solve for what's still in the problem so that all of this can be replaced by 1/4 du. So what do we got? Okay, we got the integral of, and it's 1 over square root of u times 1/4 du. Now, the one thing I didn't write the bounds down right now, and you might be like, why didn't you write the bounds down? Why didn't you write the 0 and the 2? Remember, that's what x is doing. X is going from 0 to 2, but we're not in the x land right now. We've transformed. We're in the u land instead, and so u is doing something different. So I'm going to leave it off for right now. So it's 1/4 integral of u to the negative 1/2. If you might think about it, and you might be able to figure out how to deal with that fact, but we just didn't get to it last class, so we're going to do it next class. So, or you'll have some guided notes for Wednesday. Yeah. All right. So what do we got? We got u to the 1/2. The 1/4 is just sitting there. Reciprocal goes in front. 2 over 1 plus c. Except it's not plus c. It's a definite integral. And this goes from x from 0 to 2, but I'm not in the x world. I'm in the u world right now. So let's go back to the x world. So let's see. It would be 1/2, and it's 1 plus 2x squared to the 1/2, evaluated from 0 to 2. So plug in 2. And so there's a 1/2 in front. I can just do that times everything at the end. Plug in 2. I got 4, 8, 9. Ooh, that's cute. 9 to the 1/2 minus, plug in 0 and you get 1, yes, to the 1/2. And so that's 3 minus 1, which is 2. Yeah, times 1/2. I'm getting that the answer is exactly 1. Let's check it really quick. Kind of wild to get an answer of 1 on the nose, so I'm checking it out. Graph the function. Here's the graph of it. And we're integrating this from 0 to 2. Cool. So second calc. Take the integral. Lower limit is 0. Upper limit is 2. Oh! Awesome. So that just, I just thought it was kind of weird with an answer like that. It was a little too straightforward, and I just wanted to check it, and so I checked it, and it's right. So what have I shown you? I've shown you 2 problems of each, 2 with Lindstrom and 2 with substitution. All the problems tonight should be doable with either one of them, I'm pretty sure. But you should be able to do either one. I'd say Lindstrom you'd want to be able to do because it's easier, and substitution you want to do because, well, we'll show you some examples of that really soon. Okay, that's it. Hope this helps with the homework. Bye.